Looks like tonight the sky is heavy. Feels like it's time to dream again. Hello, students. Welcome to Circles 3. This is Mr. Zacek, and we have been dealing with angles related to the circles. And just as a quick way of review, we've been talking about the key being where is the vertex of the angle, and we said when the vertex is at the center, that's a central angle, and it equals, the arc. And then in the second one, we said when the vertex is on the circle, it equals half the intercepted arc, and we called those inscribed angles. So we started off with central angles, and then we talked about inscribed angles, and today we're going to deal with another type of angle when we have a tangent to a circle. But before we get into that, I want to just give you a little bit of vocabulary. The first is the word tangent, and a tangent is a line, a segment, or it could be a ray, that intersects a circle at exactly one point. Intersects a circle, at exactly one point. And we see this picture here that we have a tangent line. That point is sometimes called the point of tangency. Where is it that it touches the circle? Now it can only be one point. The second vocabulary word that we have is a chord, and you see here that we have an example of a chord for you. And let me just get my highlighter quickly. And this is a chord. And a chord is a segment. Now it can only be a segment who has two endpoints on the circle. So it's a segment whose endpoints are on the circle. And this is just some vocabulary that's going to help us. Now, one of the things that you'll notice about a special case for a chord is that a diameter is a chord. And a diameter goes through the center. That's what's the only thing that's different about that. So we have tangent, touches at one point, and a chord which touches at 2 points, two endpoints on the circle. Now, for our theorem today, we have the tangent chord angle, and as you can read here, it's an angle formed by intersecting tangent and a chord. And again, here is the key: the vertex is on the circle. If we look at our diagram to the right, we see point B. That is on the circle. And here is what the relationship is. The measure of the angle, the measure of the angle equals half the intercepted arc. So it's not really any different than an inscribed angle, which was half the intercepted arc. The only thing that we have to be aware of here is what is the arc that we're talking about. So as we look at our diagram, here's our vertex B on the circle. If I carry it out here, I see point A is on the circle, and that is the arc that we're going to be dealing with. So it's this arc BA. And the measure of that angle is going to be half of that. So the measure of angle CBA equals 1/2 the measure of arc AB or BA. And in this diagram we have, that means x is going to equal 1/2 of 120, and x equals 60. Let me move my screen up here a little bit as we can see that. It's 60 degrees. So the other way to think of it as the arc is twice the angle. The angle is half the arc. And a specific example of that is when we have a tangent and a radius. And it's an angle formed by intersecting a tangent and a radius, has the vertex on the circle. Okay, so here is this is our tangent line. And here we have a radius. And you'll notice that a radius we can easily extend to be a diameter. Now, from our formula that we just talked about, what is it? Well, it's half of the arc. Well, that arc happens to be, in this instance, a semicircle. And we know that a semicircle is 180 degrees. Half of 180 degrees is 90 degrees. And so we get a right angle. So just to kind of summarize that, when we have a radius and a tangent, they are going to form a right angle. And again, remember that's a proof alert there because we like right angles. And we'll see that later on when we get down there. But the radius and the tangent, so it's kind of a special case that we have. All right, if we look next here, we have a couple examples that we want to go through. And the first is given tangent AC, find x. So we know that point A, that's the point of tangency here. We have segment AC, and here is our angle. So that's our thinking is vertex is on, and therefore it's going to be half of an arc. However, in this example, we see we don't have the arc that we are looking for. So if I'll highlight what arc we need, there it is. So we have to look at, well, what other information are we given? And we're given that the remaining arc is 240. So we know all the way around a circle is 360. Whoops, not divided by. 360 minus 240 is going to be 120 degrees. So this arc will be 120 degrees. Now therefore, okay, x is going to be half of 120, and x is going to be 60 degrees, half the arc. Now let's look at number 2, and in number 2, the next example, we're going to flip this around. Here we're looking for x, and I'm just going to use my highlighter again here. X is this major arc. I'm going to also highlight the other arc just so we can see the difference here. And, well, what do we have? We have an angle. And we have a point of tangency. So we have, again, vocabulary. This is a tangent. This is a chord. It's very helpful to us to get to know that. And now what's going to happen is the arc is going to equal 2 times the angle. So when we flip that around, we need to double it. So our arc in this case is going to equal 2 times 50. 2 times 50 is 100. So this is 100 degrees. Well, that's our purple arc. We still haven't found x, which is represented by the yellow arc here. But again, we know all the way around a circle is 360. So if we subtract 100 from 360, we get 260 degrees. And that's what x is going to equal. So I might just want to write x equals 260, identify that very clearly. So again, if we just compare example 1, in example 1, we had to use the arc to find the angle. So we divided by 2 or multiplied by 1/2. In example 2, we flipped it around, and we want from the angle to the arc. So instead of it getting smaller, we double it, and it gets larger. Now we just have 2 more examples, and they show us a couple of the other things that we're going to need. This one, we are trying to find x, and x represents this angle. And I want to notice again here, what is that angle? Well, the vertex is on the circle. Whenever the vertex is on, it's going to be half of the arc. Well, what is that arc? Let me use my highlighter again just to show you. It's this arc here. But I don't have any numbers. So I'm a little bit stumped here at the beginning. But what do I know? Well, I know all the way around a circle is 360. And using our arc addition postulate, I can do 3y plus 2y equals 360. So we add those together, we get 5y equals 360, and we divide by 5, and y equals, I don't have that in my head right away, so 360 divided by 5, 72. Okay, now we want to plug this back in, and we're going to do 3 times 72, because that's what we're looking for. So 3 times 72, what's that come out to be? Well, I got Jen here. She can help me out. 216. All right, so our arc is 216 degrees. Now, again, back to what we're looking for, our angle x. X is going to equal half of the intercepted arc. So half of 216, x is going to equal 108 degrees. You know, and if we needed to find the other ones, we could. So that just shows you another layer of complexity. Now, the last question that we have, we get a ratio. The segments through point A is tangent to the circle at A. And so we have our ratio here. This is what I mean when I say ratio. It's this right here. So, okay, that's a little dark, but hopefully you can see that. So AB and BC and AC are 3 to 3 to 4. Well, that means they're all going to add up all the way around to 360. So here's what I want to think about that as. All the way around a circle is 360. And so with a ratio, we got to figure out what are we going to multiply by those values to get them to be 360. And by solving this equation, we get 10x equals 360. We divide by 10, and we get x equals 36. So I want to use that to find the individual arcs here. So 3 times 36 is, I think, 108. 3 times 36, 108. And then 4 times 36 is 144. So we have an arc here of 108 degrees, 108 degrees, and 144 degrees. Now, what are we trying to find in this question? Well, we're trying to find this angle right here. Vertex is on the circle. Okay, so the vertex is on. That means it's going to equal half the arc. What arc? Well, let me use my highlighter again. And it's this arc right here. Well, we've already found that arc, so we're going to say that x equals 1/2 of 108. And 1/2 of 108 is 54. So that gives you an idea of what we have with tangent and chord. Again, just pay attention to those vocabulary terms. This is a chord. This is a tangent. Again, looking at the key here is vertex. And we just want to realize that the intercepted arc is along that circle. So if we're going to find the angle, it's half the arc. The arc is twice the angle. All right, good luck as you're doing this.